Yeah, this is the last chapter. I would like to complete maybe very soon. And most I have given you people the explanation of your program slots, right? You got your mails, right? Can anyone respond? I've sent you a Google sheet where you people have to,
We received.
you received, right? Yeah. So you people have to prepare and explain the same project what you have done. And each date we have given, and rest of them I'll intimate you later. Okay. So the people who have joined late can complete the quiz. I'll repaste the quiz again in the chat window. Complete the quiz. Okay. So we have started with uh, fifth unit, that is transaction management overview, and we have seen how the transaction will be done behind once when you just say transfer amount from A to B. So how many transactions or how many statement of code should be present in the database? That's what here this slide says to us. And we have seen about acid property. What do we mean by acid property is A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. This which we have seen, atomicity meaning is what either you execute or please don't execute. That is the work of atomicity. Consistency means even when your database, if 100 people use or 1 lakh people use your database, but it still should be in the consistent state. That is what consistency says to us. Durability, how long your database should be present. Again, depends upon what type of application you are doing. It may be for 10 years or it may be lifelong. So based on that, your durability or your system, your database should work. Isolation. So though one day how many transactions will be done in the bank, or not only in the bank, it may be anywhere, wherever we use database. Though you use 1 lakh people transaction for one day, but still each transaction for one particular person should be different or isolated from other person. That is what the isolation says to us. Then serializability. So one after the other, transaction has to be done. In case if you have a multiple transaction to be executed by the operating system, then what it has to do is it has to do one transaction at a time. At this time, these many transactions. After that, these many transactions. Then that is what is called as a serializability. Scheduling. So now each day, each hour, the timetable is there for you people to attend the class. So then that is what is called as a schedule. Same way here, even in the database also, we have to schedule which transaction has to be executed first, which one should be done next. So that is what is called as a schedule. Then serial schedule, like your linear search and binary search. In linear search, you keep searching from the first element till you keep going on till you find the element till the end. Then that is what is called a linear search. So in the same way, serial schedule means one after the other. First hour you have one subject, second hour you have some other subject, third hour you have some other subject. Then that is what is called as a serial schedule. So to resolve these problems, whatever was there in the serial schedule, so we have something called as a equivalent schedules. So now some people, we cannot say that DBMS subject will be given every day first hour. No, it is why only DBMS class should be always first hour. So that in that case, what is there in your timetable? Each staff at least should get only first hour, first one time. So that is how the timetable has been done. In the same way, equivalent schedule means equal effort should be given for all the transactions. So then how to view the equivalence class? So that's what we have seen. S1 and S2 are the two data sets, two data, and T stands for transaction. So what should be which one should start? Whether S1 should start first or S2 should start. That's what the view. And the conflict. So if two friends are there, if two friends have argument between each of them, then their friendship may break. So to avoid that, try to have a healthy transaction, healthy argument between them so that your friendship will retain. So the same way, conflict equivalence is both belongs to separate transaction, then accessing the same data becomes very difficult. Suppose you have, let me say you have DBMS notes, you have only one copy and your friend also wants the same copy and you also want the same copy, then the conflicts arises. So how to overcome that? So that's what we see in the conflict equivalence. Then we have something called as a states of transaction. So in your operating system, we have seen what are the states. So we have seen initial state. So that's what even in your, once you join first semester, which semester you are first sem. So then now which semester your third semester. So after 1 year, where you will be? You will be at the ending of MCA. After 2 years, where you will be in some company where you're working, your working life starts that. So that's how the states of your each students will be of different states. Same way here also, in the transactions also, there are different states. A transaction in the database can be in one of the following states. So active, in this state, the transaction is being executed. This is the initial state of every transaction. Partially committed, when the transaction executes its final operation, it is said to be in a partially committed state. So active means what? Presently we are using that, then we say it is active. So partially committed, when the transaction executed its final operation, it is said to be in the partially committed. Now you are in 6th semester, you are doing some project. So then what we did, you're at the end, you're at the verge of completing your MCA. Then that type of things are called as a partially committed. Then failed, sometimes your program, your execution of the program is failed. So then that is what is called as a failed. A transaction is set to be in a failed state if any of the checks made by the database recovery system fails. So sometimes you would have seen, by mistake you have deleted something. Then we have a case called as a undo, so that we can go back to the previous statement, previous operation. Same way here, failed also. So then aborted, we have completed and we want to close it. So then we say aborted. If any of the checks fails and the transaction has reached a failed state, then the recovery manager rolls back all its write operation on the database to bring their database back to its original state, where it was prior to the execution of the last transaction. So the transaction in this state is called as aborted. So the database recovery module can select one of the two operation after the transaction is aborted. Restart the transaction. Sometimes what we do, we have installed some application, then it will ask us to restart. Then what we excuse me, we restart the transaction. We go back and we say why? Because that whatever our operating system you have installed, whatever application you've installed in the operating system, the operating system may require some changes to be done. Then it will ask you restart the transaction, or whether right now I am busy with some other work, let me not restart now, I may restart later. Then that is what is called as a kill the transaction. Or committed, okay, now we can do. If the transaction executes all its operation successfully, it is said to be committed. All its effects are now permanently established on the database system. Then concurrency. So now, what is this concurrency? Best example is your test. So what we are doing, only one question paper is being not a DBMS question paper. Let me take only DBMS. DBMS question paper is shared to you in the first day of your internals. The same question paper is shared for all 50 of you, and concurrently you people will be given with only 1.5 hour time. So then within that time slot, you have to write, scan and send back. What you are doing, all 50 has to do the same work. So then that is what is called concurrency. And controlling, so now 50 of you, what you will do at 11, before 11 o'clock or 11 before 5 minutes, you start scanning is over, then you start uploading your answer script. Then everyone start uploading only that 5 minutes gap. So then the network should also support. That is what is called as a concurrency control. In a multi-programming environment where multiple transactions can be executed simultaneously. That's what I told. So many, 50 of you are executing. Imagine only MCA 50 are there. Imagine other 5th semester MCA 60. Then imagine first semester, then again 60. Only the MCA is there in BMSIT college? No, there are so many branches. Then imagine how the network should be supported concurrently. So that's what here. It is highly important to control the concurrency of the transaction. Then the internet should not mix your first sheet of your answer script and your friend's sheet of the second sheet and mix it and send to us. No. What the internet or the should be done, whole your answers should be set in one and you people send me. That's what your concurrency should be controlled. We have concurrency control protocol to ensure atomicity, isolation, and serializability of concurrent transaction. So that's what even in the transaction or concurrency. Concurrency means parallelly we are doing something. So in that case also, either you execute complete or don't execute. That is what the atomicity says to us. Isolation means if Spurti is sending, her complete answer should be separate with Rashmi's answer sheet. Rashmi's answer sheet complete should be there with the Pavitra's answer sheet. Means isolation. Each answer sheet should be separate, because though the DBMS questions you people attend are same, but each answer sheet should be different. That is what is called as isolation. Then serializability. What I do, whatever I receive, I sort them based on your USN number. I start evaluating first USN, ASTA, then 2, then 3, like this. What I am doing serially, one after the other I am doing. That is what is called as a serializability. Then to avoid this is okay because you are using them. So concurrency control protocol can be broadly divided into two categories: log based protocol and stamp based protocol. What is this log based is? Once suppose you think that DBMS note hard copy is given for 3 people and 3 people want to use the same DBMS notes at the same time. But what you people have to do, half day first student will be studying DBMS notes. So that DBMS is locked for that particular first student. Other half day, second person can use once that first person has completed his studying, second person can use the DBMS. This half day. Next day, the third person will be using. What you are doing, you are fixing the time slot. That is what is called as a lock. That book is being locked, that DBMS notes is locked for half day for one student. That is what is called as a locking. I am locking the DBMS note. When that period is locked, they have to study DBMS because later that DBMS is not available for them. That is what is a log-based protocol. And one more is there, that is what timestamp. That's what I told, half day. This much from today is Monday, tomorrow Tuesday. So tomorrow Tuesday morning 8:30 to afternoon 2 o'clock. Notes is given for Spurti for studying. She has to study at that time because after that notes will not be given to Spurti. Next person has to take. Next Asta has to complete her studying from 2 to night DBMS. If she is not studying, she will not get back that notes again. That is what the timestamp says to us. Locking and timestamp is same, but there we are using a word called as a lock. That DBMS is locked for that particular thing. Cannot be given to some other principal. That is what lock. But whereas time, here only time slots is being given, like your timetable. This time I have to take my class. 4th hour some other staff will be taking. What we are doing, we are giving a time for each particular subject. That is what is called as a timestamp based protocol. Let us see the first one, that is a log-based protocol. Database system equipped with log-based protocol use a mechanism by which any transaction cannot read or write data until it acquires an appropriate log on it. So what it says, what is lock-based protocol says to us, uses a mechanism. This lock-based protocol uses a mechanism by which any transaction cannot read or write. So I cannot start writing anything to the database, or I cannot read the database until it acquires an appropriate lock on it. So if I want this particular book now, then what we do, you have to use some lock, either reading or writing. Then that is what is called as a write data until it acquires an appropriate lock on it. So locks are of two kinds. One is binary lock, another one is shared lock. Binary, so like our switch, either I can on the switch or off the switch. Same way here, a lock on data item can be two states, either it is locked or unlocked. One more is a shared or exclusive. This type of lock mechanism differentiate the locks based on their uses. If a lock is acquired on a data item to perform a write operation, it is an exclusive lock, allowing more than one transaction to write on the same data item could lead the database into an inconsistent state. Read lock are shared because no data values is being changed. So there are four types of lock protocols available. Simplicity. First lock is a simplicity lock protocol. What this implicit lock protocol will be doing is allow the transaction to lock whenever object before a write operation is performed. So what we do, you want to change something, you want to edit your notes, then we use a implicit lock. Transaction may unlock the data item after completing the write operation. When do we unlock? I've completed editing, then I can say it is, you can unlock this. Then pre-claim lock protocol. Pre-claim protocol evaluates their operation and create a list of data items on which they need locks. Before initiating an execution, the transaction requests the system for all the locks it needs beforehand. If all the locks are guaranteed, the transaction execution and releases all the locks when all its operations are over. If all the locks are not guaranteed, the transaction roll back and wait until all the locks are granted. This locking protocol divides the execution phase of the transaction into three parts. First phase, when the transaction starts executing, it seeks permission for the lock it requires. The second part, when the transaction acquires all the locks, as soon as the transaction releases its first lock, the third phase starts. In this phase, the transaction cannot demand any new lock. It only releases the required locks. Then we have something called as a two-phase locking, has two phases. One is growing, where all the locks are being acquired by the transaction. And the second phase is shrinking. Either you can acquire or shrink, where the lock held by the transaction are being released. To claim any exclusive write lock, a transaction must first acquire a shared read lock and then upgrade it to an exclusive lock. Then we have something called as a strict two-phase locking. What is the strict two-phase locking? The first phase of the strict 2PL is same as 2PL. After acquiring all the locks in the first phase, the transaction continues to execute normally. But in contrast to 2PL, strict 2PL does not release a lock after using it. Strict 2PL holds all the locks until the commit point and releases all the lock at the time. That's what we were saying. There are two types of lock. One is lock and another one was a timestamp. So here the strict 2PL does not have a cascading abort as 2PL does. So timestamp is time is given for each. Then we start giving a value for each. That's what a timestamp based protocol is used. The most commonly used concurrency control is the timestamp. based protocol. So the timestamp based protocol, this protocol uses either system time or logic counter as a timestamp. So that's what here the timestamp, what it will do. How will the database know? So you can see here, even any of your laptops or your mobiles, you can see nowadays what you do, even in your WhatsApp also. You can just check at what time you have received the message. So now if it is, now it is 10, 11, 11:20. So you can check after 10 minutes, 11:30. Automatically the time get increased. So that type of thing is called as a time stamp. So it keeps changing, changing based on what? Based on the time. So, or sometimes some application you can set. Suppose you think that now I have told you people to complete your entry or some assignment I would have given. Suppose you assume that. So then I will say that today, by today afternoon, you have to complete. So, or you can just see your uh, uh, assessment or your question papers, your answer scripts. So we have set the time till 10:10. After 10:10, 11:10, even 1 minute also, we will be in our GCR, we will get saying that late submission. So this late submission, how we have set the time, we have given the time as it should be only this much. So that is what is called as a timestamp. So log-based protocol manages the order between the conflicting pair among transaction at the time of execution, whereas timestamp based protocol starts working as soon as the transaction is created. So what is the difference in a log based and a timestamp is, in the log based, the order between the conflicting pair, so who has to execute? So suppose now Asta is taken first. So then who has to take after Asta's? USN2. After USN2, USN3. That is what is a log based. Order also matters. Whereas in timestamp, there is no order. Who executes first? So now suppose out of 50 people who executed their program first, we will be checking their programs. So then that is what is called a timestamp. Same way here in your lab exams, out for 50 people, what we do, we give a different slots time. So first day, 3 batches. 3 batches means first 10 USN will be executed. So that is what order. There is an order. First 10, second 10, third 10. So this is a timetable given for you for your lab practical exam. But again, in this 10 people, we call at 8:30 and time given for you is till 11:30. So what is that? Log based. So you are locked with this particular time. And the order also you can see first USN 1 to 10. So these students, 10 students should be there at 8:30 of some day. Okay, so now we give you the question papers. This is what type of thing, that is log based. 3 hours you are locked. You cannot even go for the outside. You cannot step out until you execute, show the paper, everything. Then what type of this is? This is a log based protocol. Okay, now you have given and you will give you some programs and you people start executing the program. So then once you execute the program, out of 10, 8th student has written fast and executed fast because he has studied very well, and he has written very fast. Within 10 minutes he has written, within another 10 minutes he has executed. So then what is that? That is called as a timestamp. Though we have given a log 3 hours, we have told you people the maximum time for you people is 3 hours, but 8th USN student has completed his within half an hour. Then another 15 minutes for your Viva. So then within 1 hour he is completed. Then definitely that is what based on the time. So because how fast he could write, how fast he could execute, how fast he can remove, and how fast he can write the output. So that is an example for a timestamp based protocol. So starts with working as soon as the transaction is created. So every transaction has a timestamp associated with it, and the ordering is determined by the age of the transaction. A transaction created at 002 o'clock time around would be older than all the other transactions that come after it. So in the same way, you can see here your WhatsApp. So morning 8 o'clock, someone has posted. After that, after 8 o'clock also, you have so many other transactions. So, but we cannot say that is a fun. But you can see in your WhatsApp, there is a difference. There, to differentiate between yesterday's last message and today's first message, we have a word called as today. And date also will be scrolling to you. So that is how the transactions also will be displaying. So today's first message at what time? Next what time? So after that particular time, we may receive so many. So after transaction created at 002 clock time could be older than all other transaction that comes after it. For example, any transaction Y entering the system at 004 is 2 seconds younger and the priority could be given to the older one. So that's what here. For which one will we give priority? So now suppose you think that let us assume that we have a we are coming on the way. Suppose let me say you are coming from Hebbal. Okay, you're traveling from Majestic to college, and you're taking a BMTC bus. So because your class starts at 8:30, you may leave your home by 7 o'clock. When you're coming on the way, even the CM also comes from Majestic. And what we do, who will be given a priority? You or CM? Definitely your bus will be made to wait for some time till the CM moves on. So then who gets the priority? CM of this state gets the priority. In the same way, though he is older than you people, but still the priority is given for the CM. So that's what here the transaction also will be having a different things. In addition, every data item is given the latest read and write timestamp. So now, which database? Now you have some database. So what's the database? Now I have told you, I have sent you a Google Drive for you people for the DBMS lab. Who has to execute for, show me the execution or explanation of the program. Who has to do? So then I have given you a slots because 50 people are there. Right now, how till when I have given till December 17. After that, again I will give based on the, I will see, because we are trying to complete your syllabus. Then definitely I will get the free slots. Then whenever I get the free slots, other people's names I will be including. What I am doing, addition of every database will be changing. So that's what he is. In addition, whenever we have a read and write, then the timestamp will be used. Even in the timestamp also, we have a ordering. So ordering means time. So in the same way, 3 hours of exam time is given to you people. So again in the exam 3 hours, though 10 people are locked for 3 hours, but who is first? We'll call who is first USN 1. After that 2, after that 3. Like this, there is an order for you people also. That's what even in the timestamp also, we have something called as a ordering protocol. The timestamp ordering protocol ensures serializability among transactions in their conflicting read and write operation. This is the responsibility of the protocol system that the conflicting pair of tasks should be executed according to the timestamp value of the transaction. So let us take timestamp of transaction TI is denoted as TSTI. So suppose let me say transaction is TI, and what is the timestamp? What is the time taken? TS T1. So you can see even in your WhatsApp group or even in your WhatsApp, you have so many things. You have a status. You have, now if I say third semester MCA, so you have a group there. Again in that group also you can see what was the last yesterday's thing. What is the time given to that? So each message has, if we assume each message is one timestamp, and what is the time taken for that to reach? I have posted. Let me assume that I am posting join for DBMS class. When I am posting, what time each 50 of you will receive? Everyone will receive maybe within a fraction of second you will receive. So that is called as a timestamp. So in the same way, read timestamp of data item X is denoted by timestamp X. So how the timestamp, we now I'm just reading. Okay, now I have sent you that there is a DBMS class. What operation I have done? I have done a write operation. Okay, then what you people will do? Some of your classmates will say, yes, madam, we'll join. So what I am doing that, I'm reading. So what type of operation I'm doing? I can do read operation as well as write operation. So that is what uh, read timestamp and okay. So what are the two operations we are doing? We are using a read read timestamp of data, and how do we represent that? We represent that with the capital letter X is denoted by R. So why? Because R is what? R represent read. Read timestamp what? X. So the same way, how do we say write? So we use a W to say that we are doing a write operation. So write timestamp of data item X. So for which data item we want to do, then X is denoted by W timestamp X. So now same way, I have sent you a Google Sheet. So what I have sent you? I have sent you a DBMS lab. So first 6 people have to explain the projects, programs 1, 2, 3, 4, 5 on which on 26 6 students, and next December 3rd some 6 students. What did I do? I have just given the slots and I have told which program each student has to do. So then what type of operation I have done? I have written and I have sent you people. But did I give you an permission for writing there? No. So I have written and posted you people, but you cannot edit. What you can do? You can just read. So these are the two ways how we can restrict. I have restricted there so that you people cannot change. So then what type of mode I have done? I have just given a write, but what type of mode I have given for you people? I have given you people only for reading. So that's how here read and write stamps are being done. So to represent read, what is the symbol we are using? We are using a R. To represent W, write time, we are using a W. Okay, so let us take one small example and see how the transaction TI assumed as a read operation. So if a transaction TI issues a read X operation, if timestamp of TI is less than write timestamp. So now whether the time given for you people. So what is the time given for me? I have to complete my class within 11:50. I have started my class by 10:50. I have to complete my class by 11:50. Can I extend my class after 11:50? No, because there is one more class going on. Will be starting at 4th hour. What is the time for that 4th hour? 11:50 onwards. Then I cannot start the class. I cannot continue. So that's what same way here. If timestamp of TI. So what is the timestamp of TI is less than write time. If I am writing, if it is so, then what we have to do? Operation reject. We have to reject the operation. If timestamp of TI less than or equal to write time stamp of X, then you can execute the operation. So now my class is started at 10:50 and I have to complete by 11:50. So if I still extend, my class will be rejected. So that's what the first one, timestamp. Second one, I have left by 11:40 only. Is there any problem with that? No, that is okay, because the other staff will join only at 11:50. So that's how here the timestamp operation, whether it is rejected or executed. All data item timestamps, whether you write, whether you read, will be executed. Same way, what we have seen here, this is for a read. I just want to read the data item. Similarly, what we have to do with respect to write. Write means I want to edit something. If two of you, So Spurti is also editing something at the same time. Rashmi is also editing same time. So then what write operation should we, should I allow both of them at the same time? Now it is 11:35. So at 11:35, both of them can change the same database. No, I cannot allow them. One after the other, I have to allow them. That's what here. If a transaction Ti issues a write X operation, then if timestamp for Ti is less than read timestamp of X, operation is rejected. So that's what even my time is till 11:50. If my time exceeds 1 or 2 minutes, it is acceptable. If I extend my class to 12 o'clock, then other staff will start saying, please close, please close. So that's how here the time also should be closed and my operation, my class should be rejected. Suppose if I am closing my time at exactly 11:50, then fine, no problem. So then if timestamp of Ti is less than write timestamp of X, operation rejected and Ti rolled back. Otherwise, operation is executed. So for this, to do this, we have something called as a Thom's right rule. So you would have seen thumb rule in your math subjects. What is a thumb rule? These are the rules which have been given. Even in our class, in the last unit, we have told what is reflexive, what is transitive, what is Armstrong. All those were the rules. Same way here, we have a rule given by a person called as a Thomas. And what rule he has given? He has given a rule for writing when you should allow the concurrency. Many people to write. So for that we are calling it as a Thomas right rule. This rule states if timestamp of Ti is less than write time of X, then the operation is rejected and Ti is rolled back. Timestamp ordering rules can be modified to make the schedule view serializable. So what we are doing, that's what 10 people we have given exam. So for 10 people will be locked for 3 hours. Again in this locked period, order is being given. First student has to come, next to second person, USN 2, next USN 3. Like this, how many people? 10 people will be coming for 3 hours, 8:30 to 11:30. So again in this, there is a serial, right? One after the other will be given the answer script. They will pick the chat, they will write their USN on the answer script, they write their program, they execute the program. This is one after the other. But who is executing fast? Who is prepared very well is a person who is executing fast. Same way here, schedules view serializable. One after the other, though we are scheduling, but who is studied very well, he will definitely have a confidence and he will write the program very fast and execute the program. Maybe 1 or 2 errors, they will be knowing how to remove the errors. They will remove the errors, then execute the program. So the same way here, timestamp ordering rules is also important. Instead of making Ti rolled back, the write operation itself is ignored. So I'll stop here. We'll continue this in the next class. So before that, what did we do today? So we have started with last unit, that is transaction management. In that we have seen what is transaction, what is atomicity, what is consistency, what is isolation, what is durability. Then we have seen scheduling, serializability, all this we have seen. So then we have seen in case there is a conflict, there are 2 transactions to be executed parallelly, then what we have to do. Then what are the states of transaction? What is active state, what is partially committed, what is failed state. Then what is aborted, what is committed states. Then we have seen what is concurrency control. Then in the concurrency control protocol, can be broadly divided into 2 categories. One is lock based and a timestamp based. Lock means what? The 3 hours is locked for 10 students. That is called as a lock based. I am locking so that next set of students cannot allow the lab. First 10 students are locked. That is what called as a lock based. So in this lock based also, we can give some time. What is the time? 8:30 to 11:30 is the time given for 10 students. Which 10 students? USN 1 to 10. So that is what is called as a timestamp. Again, in log also, how to give the logs, to whom to give the logs. In that case, we have types of log: binary log and shared logs. Binary is what? Either I can log or unlog. Shared log, it can be shared. In the same way, now I have shared your DBMS lab. What I have done, I have shared for all 50 students. That is a shared log. Then again, in this, there are 4 types of log protocols. One is implicit log protocol. Another one is a pre-claiming log protocol. Then there is 2-phase locking, that is growing and shrinking. Then again, we have something called as a strict 2-phase locking. And we have seen about the timestamp based protocol. And we have just started with the timestamp ordering protocol. Then we have started with the Thomas Wright rule. So we'll continue this in the next class. So the people who have joined late and pasting the quiz in the chat window, you people can complete the quiz. Meanwhile, I take the attendance. Asta, answer your attendance. Asta, Abhinav, Aishwarya,
Present, ma'am.
Yes, ma'am.
Anu,
Present, ma'am.
Arbaz, Arjun,
Present, ma'am.
Ashok,
Present, ma'am.
Benita,
Present, ma'am.
Bhargavi,
Yes, ma'am.
Bhavishya,
Present, ma'am.
Chaitra,
Present, ma'am.
Devmalai,
Present, ma'am.
Diksha, Deepika,
Present, ma'am.
Deepika MB,
Present, ma'am.
Murli Krishna,
Present, ma'am.
Gangubai,
Present, ma'am.
Pujia,
Present, ma'am.
Harshit, Junjar, Kavya,
Present, ma'am.
Kishore,
Present, ma'am.
Lata,
Yes, ma'am.
Manisha,
Present, ma'am.
Manjunath,
Yes, ma'am.
Nayana,
Present, ma'am.
Neelanjan,
Yes, ma'am.
Nishant, Pavitra,
Present, ma'am.
Maithili,
Present, ma'am.
Priyanka,
Present, ma'am.
Pavan,
Present, ma'am.
Akash,
Present, ma'am.
Rajeshwari, Rakesh,
Present, ma'am.
Ramya,
Ma'am, Rajeshwari, present, ma'am.
Ramya, yeah, mark Rajeshwari, Rashmi,
Present, ma'am.
Ravi,
Yes, ma'am.
Rizwan,
Present, ma'am.
Vishal,
Present, ma'am.
Savita, Shruti,
Present, ma'am.
Sneha,
Yes, ma'am.
Spurti,
Present, ma'am.
Srinidhi,
Present, ma'am.
Srinivas,
Present, ma'am.
Sunil,
Present, ma'am.
Vaishnavi,
Present, ma'am.
Vinny,
Diksha present, ma'am.
yeah, marked Diksha.
Ma'am, Srinidhi present.
Yeah, Srinidhi marked. Okay, 2 minutes. I'll give you time to complete your chat window, then we'll stop. You complete the quiz. You people executed fifth program. Anybody can respond to me. Executed fifth program. Rashmi, Bhargavi. Anybody? Spurti. Anybody executed the program? Fifth program.
Ma'am, executing, ma'am.
It's working, Bhargavi.
Yes, ma'am, working, ma'am.
Okay, this procedures you are able to execute, right? Procedures.
Ma'am, I inserted values, ma'am. That's it. I didn't execute queries, ma'am. Still I'm doing.
You just execute and let me know if you have any problems. Like you can ask me, because
Okay,
queries
ma'am.
I think you will be knowing. First, you have to type the query procedure. Then executing the procedure is exec. Then what is the procedure name?
Okay, ma'am.
So you people please execute the fifth program and keep it ready. Okay, so we'll stop here. We'll continue in the next class.